Hi everyone, this presentation covers Chapter 26 on systematic reviews and meta-analysis in the third edition of Jacobsen's textbook, Introduction to Health Research Methods, a Practical Guide. In this chapter, you will learn that a systematic review is the careful compilation and summary of all publications relevant to a particular research topic, and a meta-analysis creates a summary statistic for the results of systematically identified articles. Here is an outline of the chapter. Section 26.1 covers an overview of tertiary analysis. Section 26.2 covers search strings. Section 26.3 covers search limiters. Section 26.4 covers supplemental searches. Section 26.5 covers eligibility criteria. Section 26.6 covers quality assessment. Section 26.7 covers data extraction. Section 26.8 covers systematic review results. Section 26.9 covers pooled analysis, and Section 26.10 covers forest plots and funnel plots. So Section 26.1 covers an overview of tertiary analysis. A tertiary analysis is a review and synthesis of existing knowledge about one well-defined topic. Figure 26.1 covers the systematic review process. This is a great figure to demonstrate the different steps that need to be conducted for a systematic review. You start with defining the study question, then define your search strategy. Then you must define your eligibility criteria for your articles. Then you search for abstracts by keywords. You screen the abstracts. Then check full text articles for eligibility. Then you extract the information needed from the full text articles, summarize your findings, and write a report. Section 26.2 covers search strings. So once you have your study question selected, your next step is to create a search strategy. The search strategy includes things like medical subject headings and keywords and Boolean operators. So these are things like and, or not, and you can include specific keywords in your search and then state whether you want two words together, like using and, or if you want to use one word or another word, or if you want to specify that you do not want to include something in that search strategy. Selected search strings should also capture several articles known to meet the eligibility criteria. And you can modify your search strings as needed to capture additional articles. So figure 26.2 goes over examples of Boolean operators in search strings. And here you can see how the different ways of putting these and, or not changes the approximate number of hits that you get in a PubMed search. And so being very specific with these different operators can give you a smaller number of more manageable articles to review. So section 26.3 goes over search limiters. Common search limiters include publication years, databases, language, and methodology. However, researchers should be cautious about limiting the number of articles that will be identified during a literature search in order to reduce the risk of missing articles. I often get asked questions by students when doing some sort of literature review what the publication limitation is, how many years back they can go to. And really that always depends on the study that's being conducting and what the aim of the study is and how many years back they want to go. That also can depend on the amount of literature that's being done. If there's a lot of literature, it may be that you want to look at a certain number of years back. It could be also that there's some sort of change in guidelines and you want to look at the literature after that change in guidelines. So it's all driven by the study question. Section 26.4 goes over supplemental searches. So in addition to searching the different databases such as Ovid, Medline, and PubMed. You can also use some other search methods. One is called snowball sampling, and this is where you're searching for more articles in the references section of the identified articles. So you find the article and then you look at the references to try and find more articles. Another is the gray literature. These are researcher reports that are not indexed in databases or journal article abstracts. So these could be things like government reports, poster or oral presentations at conferences, dissertations, and theses. Then finally we have hand searching. This is scanning articles in the table of contents of selected volumes of relevant journals to see if they might be eligible for inclusion in a review. So if you know that the American Journal of Public Health has a lot of articles related to your topic, you may want to go directly to that journal and look at their table of contents specifically. Section 26.5 goes over eligibility criteria for systematic reviews. Systematic reviews and meta-analyses require predetermined lists of inclusion and exclusion criteria, and articles should be assessed by at least 2 independent reviewers. That way, if one person thinks that you should have an article in the review and another person does not, these conversations can be had to decide whether or not it actually meets that inclusion and exclusion criteria. So figure 26.3 goes over a systematic search strategy and counts to report. Oftentimes in a systematic review you have a diagram like this, which is sometimes called the consort diagram, and it includes the number of abstracts identified from each database, and then when those abstracts are reviewed, then it includes the abstracts that are included for further review of the full text articles. Then it has the total number of full text articles reviewed, and then finally it has the total number of articles included in the analysis. So it goes in the step-by-step process of how to include and exclude different articles for your data. Section 26.6 covers quality assessment. Quality assessment should be conducted before including studies. So this should be a fair and transparent process to determine whether the studies merit inclusion in the review. Articles that appear to lack internal validity and external validity should be excluded. Section 26.7 goes over data extraction. A data extraction table allows for easy compilation and comparison of observations relevant to the study question. Section 26.8 goes over reporting of the results. Systematic reviews should include studies that find no statistically significant results for an item of interest. So we want studies that include significant findings, but we also want studies that do not have significant findings if they're published. They're just as valuable as those that find a significant association. One of the primary contributions of systematic reviews is the ability to identify both areas of consensus and areas of disagreement and uncertainty that need to be examined further in future research. So one thing that must be kept in mind is publication bias. Articles with statistically significant results are often more likely to be published than those with no results. So this is important to consider if only the studies that you are finding have significant results and are selected for inclusion in your systematic review and meta-analysis, there may be some sort of publication bias that you must account for within the reporting of your review. Section 26.9 goes over pooled analysis. So a systematic review combines all of the information together from the studies and may create some sort of themes out of what has been published previously. But the meta-analysis combines the data itself, and so it creates a summary statistic by pooling the results of studies identified during the systematic review. And it's meant to only compare statistics from similar studies that are pooled together. Statistics are used to compare the different variability in the studies. So we look to see what studies are homogeneous or similar, or heterogeneous or dissimilar. And it's recommended that if the review has a lot of dissimilar studies, that those findings should not be pulled together. And there are some different statistics that are used in order to describe the results in a meta-analysis. So the first one is Cochrane's Q, and this examines heterogeneity. It calculates a weighted sum of the squared differences between individual and pooled effects across studies. A large value for Q indicates that there is more variation across the studies than among participants included within the studies. An I-squared statistic adjusts the Q statistic based on the number of studies being pooled. A systematic review and meta-analysis may also include effect size comparisons, and this is the magnitude of the difference in the value of a statistic in independent populations. So an example here is that you could include odds ratios, as well as rate ratios, correlation coefficients, or differences in means. So if we had an odds ratio of 3.0, and it's greater than the effect size of an odds ratio of 1.05, then this is considered much further away from the null value, which is an odds ratio of 1.0. And this can be used and reported within the study. So you may have a study that has an odds ratio that's 3.0, you may have a study that has the odds ratio of 1.05. Statistical tests can assist in the evaluation and the impact of these effect sizes. When you pull these data together, you can use either a fixed effects model or a random effects model. The fixed effects model is used to create a pooled estimate when there is little variability among the studies, versus a random effects model that is used to create a pooled estimate when there is heterogeneity among the studies. And this is something that can be set within the software that you use when you pool your analysis. The point estimate for the summary measure will be similar for both model types. However, with a random effects model, it'll generate a wider 95% confidence interval. Something else that needs to be considered is weighting and the weighting of the studies. Statistical methods are used to adjust for the sampling methods, demographic differences, different sample sizes, and so forth. So each study in a pooled estimate for a meta-analysis is usually weighted based on the sample size. And these are often reported in either a forest plot or a funnel plot. And I would say that most studies in the typical journals will include a forest plot. If you look at a systematic and meta-analysis specific journal, such as the Cochrane Review, they include a lot of funnel plots in there. A forest plot displays effect sizes of the included studies and the pooled statistics. A funnel plot displays the results of the study and reviews likelihood of publication bias based on where the different dots lie in the funnel. And so figure 26.4 gives an example of a forest plot, and here you can see the point estimates are included as the boxes. And these small boxes are studies with a smaller sample size. And the large box has a large sample size. And then you can see that the confidence intervals are typically much smaller if there is a large sample size. And so this small sample size here has a much wider confidence interval here, represented by the lines. Now this diamond at the bottom is the pooled estimate and the confidence interval based on these studies. So this is including all of the results of these 4 studies up top here as a pooled estimate with confidence intervals there. And then figure 26.5 includes an example of the funnel plot, and here's where you can see how the different studies lie. This first plot has an effect size of 0, And this is a funnel where there is no effect and no publication bias. Then in this funnel, you can see there is a positive effect and no publication bias with effect size that is greater than 0. And then here you can see this is a funnel where there is a positive effect, but there's publication bias. And really all of these data points kind of lie together along one line versus spread out here in more of a funnel shape. Okay, so that is it on Chapter 26 on systematic reviews and meta-analyses. Thank you for listening.